In part one, we were evaluating our function notation when we were given a value for x. But now look at number 9. Because on number 9, they've given us function h when the value of x, whatever the value of x is going to be this equation. But over here, they didn't give us a value for x. They gave us the output. They gave us the value of the function of h when x equals x. So they've said this whole thing, this output equals 2. That means our y value is 2. So they haven't given us the x value, they've given us the y value. So all we're going to do is we're going to evaluate this, but instead of plugging in a value for x, they've given us the output, the value for y. So go ahead and pause your video and solve number 9 and write the ordered pair. Okay, so when we plugged in 2 as our y value or our output, and then we just solved the equation like normal for x this time, we came out with x is negative 4.5, or if you leave it in fraction form, x is negative 9 over 2. And then I wrote it in the ordered pair, just making sure I put my x value in the correct position in the ordered pair. Okay, pause your video and do number 10, and then check back for the answer. Okay, do notice the first thing I did on number 10 was I cleared out my fraction. I got rid of the denominator, which was 3, by multiplying all 3 terms by the number 3. And then I solved it down and I came out with x is negative 3. And when I wrote my ordered pair, I made sure to put the x in the x spot. All right, so number 11. On number 11, we're now going to look at graphs and read them based on the terminology of function notation. So look at number 11. It's given us find f of 2. So f of 2, this is our y value, this whole thing, but it's telling us it's our y value when x is 2. So we're going to go to our graph and we're going to say, okay, well, when x is 2, we go up to get on the line and say, what's our y value right there? Well, our y value right there is 1. So when x is 2, our output, our y value, is 1. That's the way that we do it. Okay, so I want you to pause the video, and I want you to work number 12 and number 13 using the graph, and then check back for your answer. Okay, so when you look at it, when they give us the x value of negative 2, we go over on the x-axis to negative 2, and we go up to our graph, and then we see what the y value is, which happens to be positive 3. And working backwards, they gave us a y value of 4. So I go up on the y-axis to positive 4, go back out onto my graph, onto my function, and then I have to go down to my x-axis to see where I'm at, which is at negative 4. All right, so now I want you to pause your video and work with your function notation using a table. Okay, so the first thing you had to do in order to answer number 14 is to complete the table. So what I did was I just took my equation, my function, and I plugged in each one of my x values through the process rule and completed my table. So there it is for 0, for negative 1, negative 2, negative 3, and negative 5. Once my table was completed, it was very simple to look at the table and fill in the answers. Okay, on number 15, I'm going to want you to complete that one completely on your own. So go ahead, before you pause your video, what you're going to do is read the entire situation first, and then complete the whole answer, and then check back for the explanation. So on part A, they gave us the x value, which was the hours. So when I wrote my function in function notation, it's f of x is 1.5. So my x is 1.5, or f of 1.5. So I plug in 1.5 for my x value and solved it out. And at 1.5 hours, the helicopter is 162.5 miles away. Part B, on the other hand, gives us the miles away and asks us how many hours has the helicopter been flying. So our 100 miles this time is our output It's our y value. It's the f of x value. So 100 equals 350 minus 125x. When I solved it, x equals 2. So at 2 hours, the helicopter is 100 miles away.